Yeah, good morning and a warm welcome from Avantor and Binder Company. And thanks for joining already our session today, which is about factors you can influence to eliminate the risk of contamination. Wow, huge sentence in your cell cultures. Or in short, 4 things you can do to avoid any contamination in your CO2 incubator. Thanks for joining. My name is Frank Krebs. I'm your host for today, together with Lothar, which is the presenter for today from company Binder. Before we really start, just a couple of housekeeping notes. You don't have to write anything down. You will get all the material shared by Lothar, including other interesting stuff right after the webinar by using a follow-up email, and we will ask you for feedback as well, of course. Please share it with us as well. Secondly, I want to mention that you can raise your questions anytime during that webinar, and we appreciate every question. And if you want to make use of your question, please press on the questions button or on this icon on the top of your screen and just raise your question there. We will be happy to answer them at the end of the webinar or depending on the nature of the question, also during the webinar itself. At the end, if any question is left which can't be answered during the webinar, we get in contact with you and are happy to answer your question right after the webinar. Okay, having said that, I hand over to our presenter for today, which is giving us all the valuable insights you are curious about. His name is Lothar Maresch. He's from the Binder Company, and a warm welcome to Lothar from my end as well. Thanks for joining us today and giving us all that great infos. The stage is yours, Lothar.
Thank you very much, Frank, for this very kind introduction. Really appreciate it. And welcome to everybody, to all of the attendees. Great you're on board today. I hope this will be as exciting for you as it is for me, because it is an everlasting story, contamination prevention. And we came up with this a couple of years ago, and to present not very product specific information, but information, let me put it, of value you can use on a daily to daily basis to improve your contamination management. Why? Because contamination, the risk of contamination, influencing that is in your hands actually. And the meaning of that, what you have right here on your screen, that title theme, you will understand in a couple of minutes, because this is the result of an experiment conducted actually by a Japanese TV station. All right, so let's dive in, ladies and gentlemen. The objective: we want to help you improve and maintain good cell culture practice by reducing the risk of contamination to an absolute minimum. We won't be able to reduce it 100%, not even in a clean room facility. Why? Because you and I, that's the way it is. We are the big contaminants, the contaminators. CO2 incubators play a major role in cell and tissue culture. And we would like to demonstrate some practical measures, 4 things or 4 chapters you should have on your radar screen when you are improving your contamination management. What can you expect? A brief intro to as a warmer-upper, consequences, sources of contamination, and very interesting survey results. My experience right here conducting this LearnLab worldwide, this is very interesting for the attendees and participants, because this is a survey conducted with 130 staff members of cell and culture laboratories in the USA and Canada. Very exciting. Major cell culture contaminants, that's going to give us a brief overview. I'm going to just tip on cross contamination an issue. And then you have those 4 things. We're going to start at the very, very beginning, because it's not only the CO2 incubator, it's not only the product itself, it is also the lab environment. And I really do mean the lab environment. Then something where many small mistakes are made, which have a larger influence on the contamination rate, is the right setting. Also specifying an ideal workstation, because as you all know, probably there's a husband and wife relationship between biological safety cabinets and CO2 incubators. And that's something I'd like to dive into a little bit more in specifics, showing you solutions, methods, technologies, how to improve your management here. Design features. This is, if we are talking to marketing people, this would be a competitor comparison, but the emphasis right here, ladies and gentlemen, is on technology and methods. I won't be mentioning brand names. I won't be mentioning any kind of model names or anything like this. This is a comparison of technology, of methods, right? For you then to use and to choose naturally, depending upon your requirements, and how to wipe, disinfect the CO2 incubator. That's the all-time, very, very frequent question we encounter here in contact with our customers. Summary, and as Frank said, questions and answer session will follow. All right, let's dive into it slowly but surely. Consequences on the left-hand side. What are the consequences of contamination in cell and tissue culture? Well, you have setbacks, loss of time, money, and valuable work. So that is a big, big issue. Adverse effects of our cultures. Those of you who have encountered mycoplasmic contamination know what I'm talking about. The loss of valuable materials, be it the cell lines themselves or expensive antibiotics or other supplements. Questionable experimental results. If the contaminants themselves are not detected, because, for example, you're not monitoring that closely enough, then anything you have in your paper, in your experiment protocols and records is basically questionable, and the embarrassment if that continues to happen in your laboratory due to the actual state of contamination management. On the right-hand side, we have typical sources of contamination. Contact with contaminated supplies, media, for example, when or outside of the biological safety cabinet, for example. Airborne fallout during culturing manipulation. Basically, if somebody forgot to maintenance HEPA filter or OPA filter in biological safety cabinets, that is a possible source. Finding their way into culture flasks, also very, very nicely if the caps are not closed, if the lids are not properly placed on the dish, on the lower dish. Contaminants, and that has to also includes cross-contamination. But by the way, as far as I'm concerned, and I know of no other person who has encountered this, cross-contamination does not take place inside of a CO2 incubator. I'll give you a nice proof right there. It's always outside or something linked to that one-step incubation. Then you have the mistakes, accidents, improper behavior. You know, if you're not following your contamination management protocols, and naturally the setup. Where do you position a CO2 incubator? Very, very simple question in your lab to reduce the risk of contamination, and the design, which we will be addressing later on. So this is a little warm-upper, and here you see, actually, regretfully, the link is inactive. Normally, I like to show this little video clip, and this is an analogy. This was done by, as I said, the Japanese TV station. The gentleman you see in the back, before lunch, that environment was symbolizing a cell and culture lab. 10 students went in for lunch, were invited to a lunch. One of them, that's the gentleman in the back, had applied to one hand, to one of his hands, a invisible fluorescent paint. 30 minutes were given for lunchtime, and then the visual light, the fluorescent light tubes of the room were shut off, and black light was turned on. And then you saw that invisible fluorescent paint start to glow. And the glow you can see right here, you can find around his mouth, his forehead, jacket. Look at the table right here where you have different spreading, the spreading of that lotion symbolizing contaminants over many, many plates, napkins, and glasses. That's how quickly that goes within 30 minutes. And that shows, and that's, I think, also where I got the idea for the title page. Things, behavior, contamination management are very, very important when you want to control the spread of contaminants. Thought that was very, very interesting. All right, next slide. An interesting survey. This survey, ladies and gentlemen, was made by Corning Incorporated, 2020, and we had over 130 participants from cell and tissue culture labs. And the first question, I think there are all 5, if I remember correctly, do you consider microbial contamination of your cultures to currently be a problem? And this was amazing for me. 50% said yes, minor. 8% said serious problems, and the rest, 30%, 33%, and 9% said, well, not at all, or we're not sure. So that's a pretty high rate, 50%, or if you want adding 50 and 80, almost 60% right here, having problems. How often is it a problem per year? Almost 70%, 1 to 5 times a year. 21%, 6 to 10 times a year, and 12% more than 10 times a year. That is the area where you say it's a monthly issue. And any contamination problem keeps you from conducting your work, keeps you from working with your cell and tissue cultures. Have you ever encountered mycoplasms? Personally, I feel that is those are the most tricky contaminants right here because difficult to detect. Have you encountered mycoplasmic contamination in any of your cultures? 10% roughly said yes, 14% several times. The 44% you see right here, not sure, that is probably a hint that these people actually are not monitoring their cell lines or tissue cultures regularly. Do you currently test your cultures? And that's a proof. 50% said no. Specific for mycoplasm, that was an issue with Corning itself, but I think that also goes for many, many other contaminants. Do you use antibiotics in your culture media? 65% said yes, usually 7% only in short issues, 17% occasionally. So almost 90% of all cell and tissue culture people, they apply in one form or other antibiotics, which is a hint for issues around contamination and contamination prevention. I found very, very interesting. Now let's dive in, ladies and gentlemen. Let me share a couple of slides right here with the more prominent one. The bacteria, molds, and yeast, very, very common. Worldwide, you can find them in cell culture laboratories. They quickly colonize and proliferate. In the absence of antibiotics, they typically enjoy 37 degrees C, like our cell and tissue cultures in the CO2 incubator. They love dark and they love humid, high humidity, like you have in the CO2 incubators, 95 and above, specifically if you're working with the open Petri dishes. They can actually be detected with the eye, with the human eye, if you find turbidity or if you're using a discolorization buffer, you have a color change, pH shift. Other than that, and then you always have the option of using a microscope. But in that case, you really do have to have a regime, a contamination management, considering all these issues. Viruses, now that's a different league. That's the next level, if you want to say, more difficult to detect than the first 3 we talked about, difficult to remove from serum, media, and other solutions, and may have a greater aversive or cytopathic effect on the cell cultures. Typically, and those are the ugly things we have right here, Epstein-Barr viruses, Lassa fever, HIV, SARS, hepatitis, that's a personal safety issue that come along with these viruses. Mycoplasms, as I said, I found very, very interesting, and I confess, ladies and gentlemen, this is a rather older survey conducted by the FDA and ATCC in the States, they estimated that at least 11 to 15% of the cell cultures in the USA were currently affected by mycoplasms. That was 2019, if I remember correctly. In Europe, they assumed that a fourth of cell cultures were affected by mycoplasms. Very, very difficult to detect here. And they have a massive influence, not only on growth, but also genetically, and the metabolism, for example. Cells cross-contamination by other cultures, that is done normally outside of a CO2 incubator. Once in a while, we have inquiries saying, can it be that we have cross-contamination taking place inside of a CO2 incubator? That is not the case. Here we have a test, 246 cell lines were shown in a survey that 25% were contaminated with HeLa cells. And there you always can expect some kind of adverse effects, making results questionable, and that is always a good idea to monitor closely the quality of your cell line and the contaminations you might have inside. Chemicals, most of you probably won't be thinking of chemicals as a severe contaminant, but if you think of the plasticizers, for example, or residuals from a wipe disinfection, many of you use 70% alcohol, others use disinfectants, detergents. If that is not wiped down correctly, then you have residual vapors inside, and that also contributes to bad cell growth. VOCs from environment. I can remember a time when I was heavily involved in IVF, in vitro fertilization. Here we encountered many cases where formaldehyde-containing soaps located on a sink in the vicinity of a CO2 incubator had a negative influence on the success rate. And things like that must be taken into consideration. Also the gas bottle. If you have issues with improper cell and tissue growth, consider also toxic impurities in your gas bottle. I'm not talking about outside. I'm talking about inside, because every empty gas bottle is cleaned before it is then refilled. And if that is not neutralized correctly, you might have a problem there. Now let me address this fairy tale cross-contamination. And to give you the proof, here we have cell line cross-contamination and accidental co-culture, a paper. And here you see as a proof, have 7 points. Accidental transfer, that you're using or mislabeling a flask, for example, thawing a wrong frozen stock, using one reservoir of media for more than one cell line is very, very typical things, but you won't find in this paper any kind of issues around cross-contamination in a CO2, directly in a CO2 incubator. So they actually don't jump into from one petri dish to another. So that's a hoax or a fairy tale, if you want. Ladies and gentlemen, we said 4 things to observe, and we're going to go and start down to the nitty-gritty, to the very basics of a cell culture laboratory. And this is the LearnLab. That's why we call this presentation a LearnLab, this format. And here you see an initial room. What you do see here, number one, no ventilation, no HVAC system, for example. You have the rough walls, you have cracks, damp corners in this room right here, condensation on windows and walls if they don't tightly seal. You have issues around draft, mold formation given this environment, this biome, if you want. So those are the things to keep a look at. These are no-goes. Fluctuating room temperatures, summertime high temperatures, wintertime low temperatures, something CO2 incubators, regardless of the brand, do not appreciate, and then in turn have a negative influence on good cell and tissue growth. Drafty doors or even drafty windows. Right? Carriers, these are highways for contaminants to enter a lab. Now you can refurbish this, and this was nicely done by Professor Know-It-All right here. And you can see the walls are nice and clean, very smooth, no cracks, molds are gone. And we have different issues, like to point out ventilation of the entire room, an HVAC system. And the ideal temperature for a cell and tissue lab is somewhere between 18 and 30 degrees. We had a representative of a cell and tissue culture company over here from Thailand, and they even said some days they even achieve 30 degrees C. But the best optimal temperature right here for a CO2 incubator is around about 22 degrees and a maximum 70% RH relative humidity. Then tight doors, very, very important. Tight windows, so you don't have any draft, you don't have any unwanted air movement. And once you have that facility established, then you can start to set your incubators. And right here, if you take a closer look, spend a second or two and visually that, I hope one or two of you or some of you will recognize some things which are not quite ideal, which can be adjusted to optimize your contamination management. And I'd like to address that. Number one, we have direct sunlight falling on CO2 incubators. If that isn't the case, you are heating it up, and that heat will disturb the temperature inside, usually 37 degrees C. You will have a temperature overshoot, and that is not good, neither for the incubator nor for your cell lines. So that is one point to have on your radar screen. Drafty doors when the door is open. Always very, very simple things. And when entering the room, open the door quickly, close it, and that's it. Placing CO2 incubators directly on the floor without any adapter plates or casters or something like that is a no-go. Because every time somebody walks by, their feet, the air movement will transport dust, carrying contamination eventually into especially the lower one. Directly stacked on top of each other is also specifically for those, and we have many, with a thermal sterilization routine. CO2 incubators too close to the door. So every time you open the door, the risk is very, very high or higher to receive contamination than a CO2 incubator stack positioned in the middle of the room. Distance from the wall, very important. So air circulates and you don't have any molds developing behind it. Usually that's about 50 millimeters. You should keep the CO2 incubators tabletop or stack away from the wall, from the rear wall. The distance between them also specified. Specifically, if you have 180 degrees C or temperatures like that. If you conduct that sterilization, if they're close to each other, you will have a temperature influence in the incubating one, which definitely you don't want to cook your cell lines. That's what I'm trying to tell you. Contaminated surfaces of the gas bottle, we just talked about the interior, now we're talking about the surfaces. Not always very clean, at least not for cell and tissue lines. Keep an eye on that. I remember once discussions with a gentleman in India when I was addressing that, and he said that was a severe problem they have because these bottles were not taken very care of during transportation and bringing them into the cell and culture lab. So that's something to keep an eye on. A water bath. A water bath frequently used by many, many staff members of a laboratory. You have an open water surface, so that's something you don't want to have close to your CO2 incubator because it is increasing the risk of contamination. Storage of supply near CO2 incubators. I'm talking about the cardboard boxes. Many of our customers, specifically those in clean room facilities, they say, no, we don't want any cardboards anymore because the recycling of that cardboard, which is good for our environment, leads to accumulation of spores inside of that recycled cardboard. And that's something you do not want to have spreading spores throughout your cell and culture lab. And HVAC not serviced. Should be done regularly. If the filter is clogged or malfunctioning, then you're spreading it once again. Open windows, don't laugh. Once in a while, we do encounter customers who say, well, it was so hot in our lab, we just opened it a couple of minutes, not very severe, not very, very long, but nevertheless, there you have an introduction of contaminants. And as with the sunlight, ladies and gentlemen, never ever place a CO2 incubator direct below a HVAC system. You have cooler air blowing on top of the surface. There you have condensation taking place inside of the incubator, and that is not good for good growth. It only supports contamination, the spreading of contamination. So those are the things very, very simple things. It's more than a handful, over a dozen of issues just by the setting of the incubator you can do to improve your contamination management. And this is a suggestion how it could be. Number one, no draft, no direct sunlight. We eliminated that in the middle of the room. Correct distance from the wall, right here, 100 millimeter. That is the usual distance. Store supplies outside of the lab. Keep the doors closed if open very, very quickly. Eliminate any kind of critical niches, which you're doing, placing it away from the door. The gas bottles, position them outside, having tubes leading then into the lab and connecting to the CO2 incubators. The correct distance, 50 millimeters between CO2, regardless of tabletop or two stacks standing next to each other. CO2 is elevated from the floor. Here you have different choices with and without casters. So here we're also reducing the risk of contamination. You have the adapter, which allows you to actually sterilize the lower one by higher temperatures and continue to incubate in the upper one. So that is also something which helps good cell and tissue culture. Frequently used equipment, good old water bath, as far as possible from a CO2 incubator. Keep the windows closed, highly advisable, and regular service your HVAC. And you see the CO2 incubators are not below that HVAC system anymore. So you've accomplished a lot with that setup. Workstation, very common, husband and wife relationship, biological safety cabinets. Here you have already the stacks, the positioning of the stacks, and the door hinges. On the right-hand side, you have a right door hinge. On the left-hand side, you have a left door hinge. And that has the big advantage for you when you're working with a biological safety cabinet. You can actually open the door to that cabinet. And you don't have to walk around that door. You're reducing the risk of contamination by doing a very, very simple exercise right here. All right, so that is the door swing. Then we have different possibilities. Here you see a little quick access. It's one little door and a big glass door. All CO2 incubators do have this big glass door. This little one right here allows you a quick access of maybe a couple of flasks for preheating or preconditioning. And the big advantage right here is the conditions inside remain rather stable compared to opening the big door, and the area where contaminants can enter is much, much smaller compared to opening the big glass door. Then we have a dual door. This is ergonomic. Something which is appreciated when you are actually changing the media. If you're passaging, you can open only in this case. That is not normal the case. The normal case is glass door remains closed and the outer door too. In this case, with a dual door, you have the opportunity to open both doors, outer door and glass door, with immediate access when you're exchanging, when you want to introduce the fresh petri dishes back into the CO2. That's a time-saving little step, not a big deal, but it also improves your contamination management. Then the water exchange. All of us know the gold standard, as you see in this picture right here, the upper left-hand side. Here you have the water pan. You also have possibilities with an external water pan, using, for example, steam humidification. And you don't have to open the glass door to exchange the water as you would with the water pan. Here you have a bag, for example, and that is done within seconds. The door remains closed, so reducing the risk of contamination. The conditions inside are stable. You're not interrupting them. And that's also something, if you have very sensitive, valuable specimens, that would be something to consider. And you have compartments. Compartments where you have dividers, not only smaller trays, you don't have a full shelf, you have smaller trays, which are very nice and neat to transport the flask, as Tina is showing here, showing us here, doing a whole row of tea flasks into that segmented compartment. That one door, same thing, stable conditions, less contamination risk, and you also have the possibility of choosing room dividers. If it is absolutely necessary, cell and tissue therapy, IVF, very, very typical, you don't want to you don't want to mix up any kind of your samples, then you take something like this, these compartment doors with the room dividers. Here in this case, stainless steel, you can autoclave the whole thing. The little trays, the stainless steel trays are also autoclavable. So this is also a step for improving contamination management. All right, CO2 incubators. Ladies and gentlemen, as I said, and we're going to stick to that, we're not going to mention any brand names, not any model names. What we have four of these for you just to demonstrate the different methods and technologies, the upsides and the downsides, from the perspective of contamination prevention. Now here, you have shelf holders. You have air ducting systems, because there we have installed a ventilator which pushes the air upward. It is recycled throughout the CO2 incubator, is drawn back over the water pan, which is standard, into a HEPA filter, and then the cycle is closed and repeats itself. You have the HEPA filter right next to the shelves and your cultures, and you have a fixed water bath. Right? So those are the things where we would say, all right, not necessarily the ideal solution when you want to prevent, when you want to improve contamination management. Because the more surface you have inside, the higher the risk something can attach to it. And that's what you find with these shelf holders and air ducting systems, for example. Or the HEPA filter has to be exchanged regularly, catches spores right next to your cell cultures. Basically, I didn't mention that I'm a biologist, work with cell and tissue culture. That's something I don't like. I don't like it by feeling, by gut feeling. Here you have the second brand, stainless steel, no ventilator inside, everything with rounded corners, and that's it. Basically, we reduce the surface to an absolute minimum, no surface, no attachment possible, easy to clean, in contrast to A. B, also a very recognized CO2 manufacturer right here, does the same thing basically as A, but draws the air upward, leads it downward, and you have a nice view of those air duct systems right here. And that is naturally also very time consuming if you're conducting wipe disinfection, or you have to have appropriate autoclaves big enough to hold these things, right? So that is also something to keep your eye on. You have a ventilator, is a maintenance part, is also surface. And we want to reduce that, so eliminate any unnecessary surface, like in B. You have a UVA lamp and hydrogen peroxide vaporizer. That is the choice of the manufacturer C. Works very nicely, but it has its upsides and its downsides. Let me put it this way, it has consequences. We'll get to that in a moment. Water bath with a cover. standard. B, by the way, also has a water pan, just to mention that. D is also a manufacturer, probably well known, stainless steel, but here you also have a air duct system. You have additional surface you need to clean, you need to attend to, and you have attachments there. The ventilator is also inside, and that was it. Now let's take the view from another perspective. What would you want to look for? 100° C routine. It's a sure kill. Copper interior philosophy. Binder, we don't offer copper in that sense. We decided that that's a company strategy. Copper is bactericidal. It does kill bacteria. My grandmother threw a copper penny in a blue flower vase to keep the flower bouquet fresh longer. So it works out very nicely, but only for bacteria. B, well, that's less is more. We're reducing, or here's a reduction of cell surface, of incubator surface, cove corners, easy to clean. And I'm not emphasizing that much quick and easy to clean, because quick and easy to clean is worth nothing if you do not clean it thoroughly, right? So that can be done much better with these cove corners, almost GLP wise. Removable water pan, 180° C routine, a short kill, stainless steel interior, deep drawn shelf holders, for example, no additional racks, no additional surfaces, decreasing the risk of contamination, no air duct system, that's something, no ventilators. If you go to C right now, here you have a UVA lamp, hydrogen peroxide vaporizer, works very nicely. Is also established in pharmacopoeia, no shelf holders, and a stainless steel interior. And D, the far right-hand side, here we also have 180° C routine and stainless steel interior. So these are the things you can choose by design. And really appreciate that comment from Corning Technical Bulletin, where they actually do state the fans used in many incubators do circulate the air, can spread spores and particulates, and that's the bottom line. So that is something you should have on your radar screen. Typical decontamination methods, here you go, 4 of them. We have the HEPA filter. Must be removed before 180° C routine, must be changed every 6 months. It is a collector. That's where I have a little stomach ache right here, right next to my cell cultures, but that is a decision everybody has to make for themselves. And you have rather large surfaces due to that air duct system. H2O2 vaporization. That was the manufacturer C. You have a continuous permanent UV light going on. It is actually health hazardous. That's something you would want to observe. Occupational health issue, working with H2O2. You need safety glasses and safety gloves. If you have something thermal, if you have HEPA filter or copper, you do not need that. Must be aware of that. No thermal routine. They rely on this chemical toxic H2O2, and have with their air duct system necessary the air duct surface. Copper interior, as I said, worked. That's an aesthetic thing. Discolorization. That I found out that is more a philosophy issue. That's like if you drive gear shift or automatic with your vehicle, both work, but it is has its consequences like discolorization. Very, very difficult once you have a crumbly surface to detect spills, and that does not promote good contamination prevention. And then you have other routines other than that 180, which many CO2 manufacturers offer standard. You have 90° C, 25 hours, which is very, very long, more than twice as long as with 180. So it's overnight at least. You're wasting a lot of time there. Still have the HEPA filter collector inside. And if you press your noses against that screen and take a look at the lower right-hand picture right here, you see a lot of bells and tubes and little HEPA filters in there. you're not going to get that clean. Just think of how difficult wipe disinfection is. So that's also something to make your life easier. And this basically is also an issue. A HEPA filter, 130 pounds, must be exchanged every 6 months. Then you have the generator right here with the 564 pounds. The bottles, 6 bottles of hydrogen peroxide, 164. UV lamps, not quite sure, probably around 300, 400 British pounds. Copper is always expensive, more expensive than stainless steel by raw material, somewhere around 1,700 euro more costly than a stainless steel. And these are things that definitely a purchasing department should have an eye on. Reoccurring costs. The Binder way right now, less is more. That's our strategy. We have no reoccurring costs. We have stainless steel for better monitoring, thorough to clean, and we have everything clean as a whistle after 11 hours. So we heat it up from 37 degrees C to 180. 180 remains there for 2 hours and then slowly but surely cools down over a period of 6 hours. If you're asking yourself, why does it take so long? Very simple, there's no cooling system. It's like your oven at home. When the cake is out of the oven or the roast, it takes some time for the oven to cool down. So that's the issue. And that is very prominent for many, many manufacturers. Wipe disinfection, slowly but surely wrapping up this session right here. Clean as a whistle. What can you use? The exterior surfaces should be considered. The control panel, the handle. Here you can use commercially available detergents, but all of them must be free of acids and halides, because if they contain acids and halides, corrosion risk will increase, and that is not only an aesthetic thing, but also has to do with reliability and contamination prevention. Alcohol, naturally 70%, is okay, or neutral cleaning agents. The door sealing can be also removed from the door carefully, and you can clean that with 70% alcohol, for example. The inner chamber, the shelves you can take out, you can take the water pan out, the racks you can take out. They can be brought into an autoclave, or you can put that in your labware washer, depending upon the size of that washer, or you can go through the same process, wipe disinfection, detergents free of acids and halides. Always make sure of that, or you use or establish a routine including 70% alcohol. Water pan, same issue, all right? Also works very, very nicely in a lab washer, or if you enjoy the 180 degrees C sterilization, you can keep the shelves and the water pan inside during that treatment. And then it's clean as a whistle at 37 degrees C, ready to load after 11 hours. And many of the incubators also have a countdown when you're working with a 180 sterilization. Recommended, a lot of questions. We receive a lot of questions. How often do I have to exchange the water? We, as a manufacturer, and everybody else says ideal, in an ideal world, 2 to 3 times a week. You and I know that not natural, that isn't the case. But the more frequently you do that, the less the contamination risk. Many of our customers ask, can we put copper chips or a copper penny or whatever inside of the water pen? Yes, you can, because then you have that bactericidal effect, or more so EDTA concentrations between 1 to 5 micromole is also possible. Some of our customers use that. Sterile filter, and get this correctly, ladies and gentlemen, I'm not talking about the HEPA filter inside as with Model A. I'm talking about a HEPA filter, a particle filter from the gas coming from the gas bottles. Before it enters the CO2 incubator, the particles coming from that gas bottles are caught by a syringe filter type little filter. All right, and that also has to be exchanged 1 to 2 times a year to ensure a good CO2 supply. And sensors. Many sensors, CO2 sensors, oxygen sensors, if you have a CO2 or so-called tri-gas incubators there, as well as the humidity sensor, they can be sterilized at 180 degrees C. They remain inside and everything is actually clean as a whistle for your next setup. So that's also something to consider. And naturally 180 gold standard nowadays. Then, as already shown and mentioned, how to exchange that external water bath. Here you have that. The tubes, normally you can autoclave, clean with 70% alcohol. That is easy. If you have a tank feeding multiple CO2 incubators, that is also possible to disinfect them with 70% alcohol. The exterior water bath can be accessible from front, like here, or it can be positioned on the right or left hand side of the unit, mounted in the housing where you can refill it over specific connections. So that's also something to consider, regular exchange of the container. Summary, ladies and gentlemen, contamination, I think that's very clear, you and I know, is a never-ending story. I had a nice discussion with Frank just before our session right here, mainly because humans are the biggest contaminators. Don't take it personal right here, it's just the bottom line. Training, contamination preventing behavior is key. Regular monitoring, as the Corning survey showed, is also very, very important to detect if you're on the right track. And CO2 incubators by design and by wipe disinfection and your environment, think of the LearnLab, the setting, can contribute significantly to reducing the risk of contamination and thereby ensuring a better cell culture growth in your laboratories. And with that, ladies and gentlemen, thank you for joining us and have a great day.
Yeah, thank you, Lothar. I'm just checking our question area if there is a question left which we should answer on right now. No, all questions answered, Lothar. That means great job done. Thank you already for that one. And for the participants, as I said before, we will send you a follow-up mail right after that webinar with all the details, materials presented by Lothar currently. And if any questions might be left, and we all know that the real questions will come during the live day in your lab, during your standard work, don't hesitate to contact us through the mail address of our webinar at avantosciences.com. And having said that, a new question arrived. Okay, so Lothar, question to you finally. How often do we clean the interior of the incubator? Or I guess it should be written like, how often should we clean the incubator?
We as a manufacturer, the more frequently, the better it is. By experience, I know, traveled the world, visited various cell and tissue culture laboratories, and I got a huge range. If you're in pharma, for example, and you have standing SOPs, regardless if there's a contamination issue or not, they do that on a weekly or 2 weekly basis to really ensure a low risk of contamination and excellent contamination management. If you go more into the academic area, that's my experience, then you get a lot of answers. Every time we encounter contamination, that's when we start wipe disinfecting them or conducting the 180 degrees C or whatever it is. So the one side is preventive, the other side is reacting when something like that occurs. So from our side, basically, and I'm not gonna specify how often a month or whatever it is, but the more frequent it is, the better it is. We actually recommend a preventive strategy rather do it one time too many than one time too late. And I hope this, I know it's a wishy-washy answer. Sorry, but
But
I
it's
know.
by nature, Lothar. Yeah, yeah, I
But
know.
but but that's our experience and my personal experience in this area. I hope that that answers your question a little bit.
Yes, I'm just checking. So a new question. Just let me dive into that one. So in our lab, we add copper
Yep.
sulfate, as far as I saw that, salt to the incubator water. Would it be less effective than using solid copper? So using the salt of copper is less effective than solid copper. I guess I know the answer, but up to you, Lothar.
Copper sulfate. Yeah. Well, the only issue I have, well, both of are definitely something you would want to consider to reduce the risk of contamination in coming from the water bath. Personally, I would prefer a raw material, a copper chip, a penny, or whatever it is, a slice of copper, copper sulfate. I don't know how that is. It might evaporate over time. As you know, the water evaporates from the water pan and then might be carried in a petri dish. I'm not quite sure and have an unwanted, unexpected influence.
Hmm.
But my preference or our preference is basically is the raw material copper.
Yeah, a solid one. Yeah, I would recommend the same.
Yeah.
Exactly. Thanks for that. Another question, Lothar. Does it make sense to sterilize incubator parts in an autoclave, basically? Um, so do you recommend that, or is there any need to put it that way around? Is there any need for an external decontamination routine as well in your mind?
If I understand the question correctly, the question is sterilization with an autoclave versus sterilization inside of a CO2 incubator. If that is
Uh,
so,
mm,
yes.
I guess it's something different. He asked before because of the possibility of contamination during putting the parts back in the incubator. So
On the way from
his
the
incubator
autoclave
and sterilizer
back.
are in different room at different floors. I guess that's, yeah, sorry for
That
that.
that 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 basically would not be ideal. I would definitely recommend 180 with the CO2 incubator because it's in the facility. When it cools down, most of the manufacturers cool them down to 37 degrees C, and you're ready to load. There's a very low risk of contamination. If you're, I remember University of Heidelberg where I studied many moons ago when I was young and handsome, our autoclaves were in the basement. So if I would take the freshly autoclaved parts up to the first or second floor, that's not that good because there you have an increased risk of contamination. In contrast to the 180 conducted
From the
um,
surface, yeah, yeah, yeah.
directly in the incubator. So that's also it's more convenient. I mean, that's also a side effect. Did I answer your question?
I think yes, and aside what you shared, Lothar, I was in labs in the past, so I think it will be, for me, I would feel unsafe in doing so, right? So in a way, regardless if that is effectively unsafe, yes or no, from a scientific point of view, but if I travel the parts around the building, I would be, and if there
Hmm.
is, imagine if there is any contamination then faced, uh, the, the the search for the error or the root cause will be, I guess,
Yep.
you
More
have to
time
invest
consuming.
more time. Yeah, so
Yeah, I
I would
agree. I
be somewhat
agree.
honest. Yeah. Okay, then last but not least, as we have 5 minutes left, but don't worry, we take all your questions right after the webinar if we can't answer on them all in the webinar. But let's me check on that one. Um, sorry, just have, yeah. Uh, the 180-degree treatment has to be in a specific incubator or in any incubator?
No, the incubator, good question. The incubator has to be designed to deal with 180 degrees C. An incubator, remember the C version, the C model I showed you, where you have the hydrogen peroxide solution with the UVA lamp or the UV lamp inside. That basically is not designed to deal with 180 degrees C. That is a different
Yeah.
method. So if you're interested in that, you have a choice between various models doing 180, but those models that do not offer that standard or have an option, and there you really have to dive into the brochure material of the manufacturer. That will work. That won't
Okay.
work because it will be detrimental for the lifetime of the CO2 incubators. That's our experience.
Okay. As we still have 4 minutes left. A question about the water pan itself. Should the water in the water pan be autoclaved, or is it better to put a disinfection inside, as we talked about previously, about put some copper in or EDTA or something in that?
Yeah.
What is your opinion on that one, Lothar?
Oh, that's a good question.
Yeah.
From what we know right here, sterile water for the humidification is basically the top-notch method to reduce the risk of contamination coming from the humidification system. Water pan is one humidification system. The external water bath is the other type we have with various brands and models. For the that's our experience for customers in a highly regulated environment. I'm thinking of pharma, biopharma. I'm thinking of cell and gene therapy, things like that. They're definitely sterilized medicinal quality water would be the appropriate solution. Um, for the rest, cell-based assays, even IVF, many IVF laboratories also rely on water pans. I don't think sterile water in that sense would really be necessary. If somebody wants to do that, just to tweak one notch higher the contamination management, improve that, then they can do that because stainless steel deals very well with sterile water. But that basically is application specific. That wouldn't want to recommend that in general by rule of thumb. Okay? Hello?
Yeah, sorry, I muted myself, Lothar. Sorry. A last question, but don't be worried. Yeah, we will come back to you with all your questions right after that webinar. So whatever is left, we will happy to answer on that. But one question left: is it okay to use bleach solutions to clean up the surfaces of the CO2 incubator? They usually use Lothar chloride solutions to clean the parts of the incubator, but they still
Mhm.
face issues when it comes to contamination.
Well, I
That's
wouldn't
a tricky one,
recommend
I
that.
guess. Mm.
I don't. I wouldn't. Definitely wouldn't recommend bleaches. If you remember that white disinfection, that was part four. One of the four things, part four. Any detergent or agent containing acids or chlorides, for example, over time will definitely harm the surfaces, lead to corrosion, even if it's stainless steel, for example. There, we then, at least I know from our user manual how to clean our incubators. There, we recommend a neutral agent or 70% alcohol in combination with using sterile water to rinse it out, so whatever. But we do clearly state that anything containing acids or chlorides should not be used. We don't recommend that, just to keep that CO2 incubator in a proper state, full functional. But that's a decision that even goes into the SOP area. But that's what we say as a manufacturer. You're naturally free to do whatever you want to.
Okay. Thanks, Lothar. So, and I said before, a lot of questions still are incoming, Lothar. So I guess you made all the folks really curious about to get more insight. So don't worry, as I said before, we'll come back right after the webinar to you guys and answering all your questions. As said, or having said that, I want to close that webinar. Thanks again, Lothar, for giving us all that valuable insights. And the
Pleasure.
follow-up mail will come during the day. And with all the materials shared, and as said, all questions will be answered by us, of course, very soon, as soon as possible. Thank you for joining us today. Have a great rest of the day as well, and join the next webinar. Thank you. Bye-bye.
Bye-bye, everybody.